Okay, welcome everybody. Happy New Year's. This is our first meeting, 2023, for Lifecycle Provisioning Technical Working Group in OPI. I wanted to ease kind of the start of the year, and I know a lot of people have been on vacation. I personally have no idea what we're working on. I need time to go back and remember. So I wanted to use today time, unless other people have different suggestions, just to quickly go and refresh what is going on, what we're working on, have a quick update, and we can finish early, or we can, stay and answer people questions. If anybody has anything specific to add to the agenda, now it's time. Please feel free to add to the agenda.
Sounds good.
Okay, cool. Okay, so again, this is our main page. We're having like 5 different topics that we are working on in parallel. Discovery and provisioning, inventory, boot sequencing, lifecycle and updates, monitoring and telemetry. Let's go through all of them and try to figure out what is going on here, just to make sure we're all on the same page. So I'm starting with discovery and provisioning. On the provisioning, I remind you, we're all working on SZTP currently. I created SZTP separate repository on GitHub. So in SZTP, what we implemented, we have the DHCP client, DHCP server. We implemented the new SZTP agent. This is a Go implementation of agent running on every DPU and IPU that can start and ask for provisioning from the Bootstrap server. We have the SZTP Bootstrap server implementation here that we took from Watson Networks just to test our agent. And we have the simulator as well going on. And we have the web server that serves as files. All of that running CI/CD pipeline, have quite good code coverage, excellent report in Go, and all the diagrams, how it is working, are right here. So if you have any questions, feel free to ask. As I mentioned earlier, we have DHCP server, which is serving 143 option. We have our Bootstrap SZTP server with PorosDB internally. We have our web server that serves all the files, and we have DPU and IPU that is running SZTP agent, communicating with DHCP client, and basically communicating with DHCP server, SZTP Bootstrap server, and HTTP server in order to do the provisioning. People start to remember what we're doing here. Any questions? All right.
Maybe just a general clarification. So all these communications, is it on the secure TLS type of a connectivity, or how is it?
Yes, absolutely.
Yeah. Okay.
There is a SSL connection, except for DHCP. As described in the documentation, DHCP is only needed to fetch the Bootstrap server URL. We are 143 options, so we do assume that DHCP is not secure and untrusted. So all of that is described here. All the rest communication wise DHCP work is being done to the Bootstrap server. All those communications are completely secure with TLS. Same for the file server to fetch all the artifacts. This is a good page for people who want to refresh themselves on the SZTP and how we implemented that. All of that is on this markdown page here. Right. Moving on to inventory. In inventory, I remind you, we identified different types of inventory. We started with local inventory. Local inventory means that applications running inside DPU and IPU want to have access to different hardware and firmware attributes of inventory of the DPU and IPU. So it made sense, and we voted and adopted SMBIOS DMI tables to fetch this information locally. This is not for remote inventory, only for local inventory. So again, applications that running on the DPU and IPU can use the DMI tables using DMI decode utility or sysclass DMI ID, sysfs, to fetch the information from DPUs and IPUs locally. Why we started with this? Because for previous SZTP work, SZTP agent, one of the things he requires is the serial number of the DPU and IPU. So we wanted to fetch it from the, I think from the system table or baseboard, I don't remember, the serial number of the DPU and IPU to send it to the Bootstrap server. This one, yeah. So from the system table. So this is why we needed to solve the local inventory. So we went ahead and worked separately offline and proposed this for adoption, and this was adopted as a local inventory. Those are the tables that currently described in DMI and DMI decode. We want to take a subset of all these tables, and in each table, subset of all the fields, and mandate them in OPI. I don't personally believe that we should mandate like all of the tables and all of the fields, but something that makes sense in OPI as a mandatory. All the rest can be implemented by vendors, no problem there. In order to check compliance, I remind you that we created a repository called SMBIOS validation tool. I cloned it from Google. Repository lives here, SMBIOS validation tool. Basically, this repository helps us validate all these mandatory fields and values. We can actually run the simple script from this SMBIOS validation tool repository inside the DPU and IPU. It is using DMI parser and will actually throw exceptions if some of the tables or some of the fields in the tables are missing. So we are going to use this repository and this validation tool in order to check compliance of different hardware vendors that produces DPUs and IPUs, if they are compliant or non-compliant to the OPI for local inventory using DMI SMBIOS. Any questions on the local inventory? I posted a few examples from Dell servers, from NVIDIA DPU, and from Marvell DPU here. I don't have yet Intel DPU response in DMI decode form, so once it's available, we will also post it here as well. Okay, so this is local inventory. Now moving to remote inventory, I split remote inventory into two categories. First is remote network inventory. So remote network inventory is you come from the network. Network could be external or internal, but basically you come through the network and you want to fetch the inventory. So we have two options that I think we haven't voted on this, but this is a work in progress direction. We have two options, Redfish or gRPC, or maybe both of them. Redfish, I don't think we need to kind of deep dive too much here. You all know or can read about Redfish specs and mock-ups of Redfish servers and schematics and everything. So this is pretty well understood in the industry for servers. For gRPC, I wanted to give you an update what happened before the holidays. So before the holidays, me and Mark, we defined the gRPC server with single RPC call for inventory. We defined it in this proto file. So Mark started and I enhanced it. I'll show you in a second. My internet is slow today, so I apologize. So basically, I wanted to struct the protobuf file to match the local SMBIOS DMI tables. So you will see the BIOS system, baseboard, and all the other tables being defined as separate messages. So you can see here, BIOS info, system info, chassis info, baseboard info, CPU info, memory info. And we define a single service, inventory service, which has a single RPC, inventory get request, and it is empty request, and inventory get response. Response in a single message can get you all this information on BIOS system, baseboard, and everything. So this is a protobuf definition that we did with Mark. In order for this not to be just a protobuf definitions, because I believe that every time we define a protobuf, we need to also implement it. So in order to have the implementation, I created a new GitHub repository called OPI SMBIOS Bridge. So this is implementation in Go language for inventory. So basically it uses this protobuf file and implements the protobuf server. So what I did is very simple work here. I basically translated DMI SMBIOS code to gRPC query. So I implemented a single function here in the inventory service, which is in inventory get. I used the existing very common Golang library for hardware information. This is basically the MIDI code SMBIOS compliant library. Red Hat recommended to use it, so I used that library. And basically, I fetch all the information: CPU, memory, chassis, BIOS, baseboard, and everything. Put everything in a single response, and return this response to the user. So this is the main code. You see, it's very small code, because it's basically the translation layer, but I already tested it. You can run it on servers, inside the GPUs and IPUs. And basically, yes, hello.
Yeah, I mean, complete your thought, and then maybe I can just have a clarification comment later.
No, go ahead.
Okay, so the comment was about the protobuf definition file, which you were showing previously.
Yeah.
Is it a standardized protobuf file, or is it something specific for the Dell servers only?
I believe that this is a standard for all the DPUs and APUs. We haven't voted on this yet, but this is a proposal. We said on the previous meetings that in order to move forward with this Redfish and gRPC, we want to create a protobuf definition for review. So this is a draft for review of this group. We want people to be able to comment on this proposal, suggest pull requests for changes and everything. You can see here, for example, I cut corners and defined like dates and times as strings instead of using the correct Google protobuf definitions for dates and times, versions. So everything is simplified to strings today. So this is just a first version, first draft.
Okay.
So I want people to comment on this, create pull requests if they want to change things. For CPU, for example, I have very limited, only 2 fields. For memory as well. Some have a little bit more information, some are missing information. But basically, this is the first draft of how the gRPC protobuf would look like. Once we all comment on this, create more pull requests, kind of agree on it, we can vote on it in the technical steering committee, for example, or we feel that we don't need to vote and just accept this as a standard definition.
Okay, so maybe another editorial comment. I see in the banner the Dell copyright, so that was the confusion. I thought like, okay, this is something which is specific to Dell servers only, and So it's
every
just an
time,
example.
yeah, in open source, usually, and in OPI specifically, we decided that each file having the simplified SPDX licensing notification with copyright, every person who is touching the file and editing it adds a new copyright line of code. And this is how we've been operating on this so far. So you see some files that have 5 company copyrights, you see some files that have other copyrights, but copyright.
So it's more of a co-signing than.
Exactly.
Sort of.
This is a copyright signing. Exactly. This is a signing method and not indicative of this is only applicable to Dell or anything.
Okay, gotcha.
This is just to maintain the copyright of individual companies while we're doing this open source work. But it's still Apache 2 license, so no worries.
Okay, thank you.
So on this work stream, excellent question, Alok. I want people to review this protobuf definition. If they feel that they need to change something, feel free. This is absolutely work in progress, so create pull requests on these protobuf definitions. The only request is because I don't want to protobuf to be kind of hanging alone without any implementation. So every time you propose a change, you need to propose a change to the OPI Symbios bridge implementation. Again, it's very little code, but we should keep this, I think, in sync. I created this Symbios bridge. Yeah, so you see, this is just 50 lines of code actually. As you can see, I created this in an image of other Go plugins. So we can compile it as a build mode plugin. It creates a shared library. We can load the shared library in any application. And it also has a main function. So we can also run it like this, using Docker or without Docker. It's listening and implementing only inventory servers, or we can use as a shared library plugins and have a single main file that implements all the services, including storage, front and back end, including networking that we started to work, including IPsec, all the different proto definitions and services that we implemented, we can use in that way. So you have two types of usage here for the same implementation, either as main single gRPC service or as a plugin shared library that you can load into other applications. This is how it looks like, the response. I tested it on Bluefield 2 Mellanox DPU card. I run it like this, using the gRPC CLI, call JSON, inventory get, has no input parameters. As an output, I got all the strings, so you can see exactly how the implementation looks like. Make sense, everybody? Any questions? Comments? People feel like this is useful, this is great work, this is waste of time.
This is great work, Boris. I think this is very helpful. Thank you.
So Vipin, for you, obviously, you don't have DMI Symbios yet. So I believe that Pensando can implement the same protobuf definitions, plus enhanced definitions, and we can have also the example from Pensando how it will look like as well.
Yeah, makes sense.
Yeah, and because you already have the defined protobuf, so again, I expect to pull requests from you to change or add more fields. We are very welcoming any contribution. As usual.
Yeah, I'll do that.
So hope this shows you that we really moving forward and really moving forward fast. If you feel this is too fast, like let me know. If people feeling that they're not having enough time to do code reviews or their contribution is somehow not welcomed or anything like that, I don't want this group to feel like I'm doing all the work or selected group of people is doing all the work or proposing the changes. This is truly open source collaborative thing that we all need to get behind it. Okay, so let's move to the next topic of remote inventory. This remote inventory, so we talked about network. This remote inventory, I called it host or BMC inventory. So when application is running on the host and DPU is inserted in the host, we feel that Redfish and gRPC are not the best methods. They can be used as well, but they're probably not the best methods to fetch all the remote inventory information from the DPU card. For example, today Dell implemented NCSI channel between the BMC and DPUs. We also have PLDMs. NVIDIA, I know, implemented VPD for the host. So we can use a vendor vital product data, VPD, over PCI Express. So there are different methods how you can fetch information, the inventory information remotely, either from the host the DPU is inserted in or from the platform BMC. So this is not yet explored section. So I feel that in the next upcoming weeks, I really welcome people's thoughts, contributions, and discussions around this as well. What are the best protocols to discuss, to try to standardize? I hope the idea is simple. The applications that running either inside host want to access the information over PCI Express, or the applications running inside the BMC want to access information from the DPU. This is the reasoning behind this section. This is just one example how the VPD data looks like, again, on NVIDIA Bluefield 2 card. So you can see some are vendor specific and some are standardized fields like part number and serial number are standardized, and there are a lot of things that are vendor specific. Any questions, comments?
Just a quick comment, Boris. I
Yes.
replied to Dmitry on Slack about what we as Intel planning to do. So we had some internal discussions, and plan is to have a separate serial number and separate UID. I think here for this UID, it's a V3 vendor specific, but ID is same. In our case, we will have serial number, and the serial number will be based on what we've done so far on our foundational NICs when we have MAC address of port 0 and we modified to present it as a serial number, and same serial number will be exposed through all different methods we have, like SMBIS, VPD, Redfish, and so on. But in addition to that, we will have UUID as well, which is vendor specific in this case. So yeah, we hope that we'll be compliant with this format as well.
Excellent. And once you have the running example, please feel free to just edit here, like I did with NVIDIA, on either either VPD, or here for DMI decode SMBIOS, or Redfish, or gRPC. I think that examples on how this exactly looks like are extremely helpful. So I would like also, of course, from Intel and others to show how the examples, how people can actually use it. So once you have any kind of data, please share.
Yeah, sure.
Thank you. So this is all the work that's been done for inventory. If you have any questions, feel free to ask more while we're moving to the boot sequencing. Okay, boot sequencing. So first of all, disclaimer, right? I have a pretty good idea how the boot sequencing should look like, but I created this page specifically without any answers or directions. I do feel like I'm doing quite a lot here, and I want maybe to start a conversation instead of forcing opinion or implementation. This is why a lot of people ask me offline, Slack, email, or whatever, like why we have a lot of questions here, but not a lot of answers. And this is by design. When I created this page, again, I wanted more to steer the conversation and direction and not reveal all the answers. Partially because I want other people to contribute, and partially because we still NDA'd with different vendors and VMware how we implemented the boot sequencing. So I didn't want to break any NDAs and reveal any internal information from Dell. But basically, let's just recap. So we have all these entities that potentially participating or optionally participating in the reboot and shutdown sequencing. So we have our platform UEFI and BIOS of the server itself. We have the platform BMC of the server, if there is a server. We have the DPU IPU BMC optionally, and we have the DPU IPU ATF UEFI BIOS. And we optionally can have additional DPUs and IPUs in the same server. So we identify several sequences that need to happen. The boot up describing the initial power on sequencing. So everything is shut down, no power. Server receives power. Server is providing power for DPUs and IPUs. So DPU immediately receives power and starts booting. So we feel that this is the point when DPU and server need to be sequenced properly in order to boot properly. For example, if server wants to boot of the either network or emulated NVMe device, for example, we need DPU to finish booting, bootstrap all the services, provision all the storage, whatever is needed, and only then server can continue boot. So here we feel that there are use cases that we need to solve that host OS should wait for DPU to finish booting. How it's done, again, I want to leave it to this group to throw ideas and understand how exactly the best way to do it. We had discussions with all the vendor participants on this call, recently with Intel and previously with AMD Pensando and NVIDIA, obviously. So we as Dell privately had all this conversation with you folks. We presented our view, how to do the sequencing, whether using OEM commands or in the standard way, maybe something on PCI Express bus. But this is a problem that we need to solve. And instead of imposing my opinion, I want this group to come to a standard way across all the DPUs and APU vendors. We do want this to be standard. I don't myself like very much the OEM commands. So regardless of how it's implemented today, I want this to be kind of a good proposal that everybody can align to. Dell and HP and Lenovo from the server side and others versus DPU vendors, AMD, Pensando, NVIDIA, Marvell, and Intel as well. So how we do the initial sequencing. And the problem is here because when server is booted up, DPU immediately powers on and starts booting, same with host OS. So there is no sequencing exists today. So we need to sequence between them. Some of the questions here is for how long should we wait? For example, we halted host OS. So host OS is waiting for DPU to finish booting. What happens if DPU never finishes or we miss the notification that DPU finished booting? Should host at some point continue to boot after a timeout or something like that? All of that questions I think asked here. Any question make sense?
It does. Do you want us to issue PRs against this page, or do you want to start a separate page for the discussion?
Whatever you feel like. Anyways, I want this to be a main page. If you start a new page, we should add links specifically to different pages from this page, but I want this to be a main page entrance into all the sequencing. Yeah. And I know Dell agenda, and I also very interested to hear a vendor's agenda, because I also heard a lot of vendors are not digging into OEM commands, so maybe a standard way doing that is what we need. Second sequencing is a reboot sequence. So we do assume that any DPU firmware reboot, not the lightweight application on the DPU reboot, but the firmware reboot of DPU, because of the downport containment on the PCI Express bus and lack of surprise removal in PCI Express, hot plug surprise removal, like very good support, some OSs will crash. Not all in all cases, but sometimes it will crash. So we feel that we need to solve how DPU can do the firmware reboot coordinated with HostOS. Do we need somehow to notify? If we do notify, how we do it? Can we do through some kind of IRQ? Is it only x86 specific or ARM hosts? We have system SMI, system management interrupts or whatever as well. So I don't know how to solve it. And again, I want this group to solve it somehow. So the idea here is DPU wants to reboot the most harsh reboot that you can think of, like firmware related to PCI Express presentation, for example, and how we coordinated this reboot with the host. Today, you can play with PCI Express configuration, master bus, downport containment, all the different stuff. So I don't know how exactly to solve it, but we want to solve it. Some people run application like agent on the host OS. I want us to try to solve it without agent running on the host OS. But if we cannot, then this is always an option.
Boris, and you mentioned PCI. Do you mean that for some reason, if I reboot, reset, or whatever happens with XPU, and while doing so, it will change PCI topology, it will cause some problems with host. So do we expect that PCI topology can be changed without proper, I don't know, notification or configuration of host?
Even without the topology change, if you just reboot the piece of firmware, the OS will experience a surprise removal and hot plug event. Those are not well handled today by OSs. Linux has better support, depends if you have a switch or not switch, depending if you have Intel CPU or AMD CPU or ARM CPU on the host. So the downport containment is handled very differently. We do see in most of the cases when we do harsh reset of the DPU, PCI Express related, even without changing the topology, the host OS will crash. So the downport containment default handler today is just to reboot the Linux. I'm talking about Linux for a second. So today in Linux kernel, if you have the surprise removal of the PCI Express device, and we are here talking about DPU, then the Linux kernel will reboot itself. So we don't want that. We want to avoid that, and we want somehow to notify maybe, I don't know, right? This is a proposal. Maybe to notify that DPU is going to reboot, and host should be somehow aware that this is going to happen, and take some measures, either automatic or manual ones, in order to allow DPU to reboot itself. One option, for example, is to disable the PCI Express bus, and then DPU can reboot and then re-enable PCI Express bus for some reason. So I don't know what is the solution, but this is a problem. Make sense?
Yeah, makes sense. Yes, for me, it was just a difference between just rebooting, resetting with same PCI topology, or when we
even with the same PCI
extra.
topology, we do feel there is a problem.
Okay, yeah, thank you.
Once we solve the same topology, we can now start discussion on the change of topology, obviously. The other workflow that we currently looking into, the graceful shutdown. So the notification here is the opposite direction. Should host notify somehow to DPU when the reboot is requested? So let's say we are in Linux on the host, we typing reboot or shutdown -R command. Do we need somehow to notify DPU that the host is now rebooting? Okay, maybe this can be done automatically through the PCI Express. I think Marvell has a suggestion in that area, so that through the PCI Express you can know that host is rebooting. I think that they added it here. Yeah, I think this is a comment from Marvell that using the burst signal from the host, DPU can know. I have no problem with this suggestion. If everybody is comfortable, we can vote that this is the only way that we signal host using the burst signal. But the idea here is in the graceful shutdown is somehow host now needs to notify DPU. And this notification, for example, some vendors asked us to notify the DPU in order to free some reallocated resources for this host. So this is why this notification is needed. So again, in previous ones is DPU wants to reboot and DPU notifies the host. This one is host needs to reboot and host need to notify to DPU that the reboot is needed. Make sense? And the distinction between the two cases?
Yeah, it makes perfect sense. Yeah, especially if yes, you have some resources or you have to do something with your, I don't know, SSD or whatever you want to gracefully shut down your IPU before it will be powered down. Yeah.
Excellent. And again, I don't have answers here. Marvell added the suggestion to use PCI Express reset signal. So I'm not against it. I'm just not sure. I'm not aware that we all agreed on this. If we want, on the next meeting, we can deep dive into this and vote on this, for example. But I want people to just deep dive and understand what is going on. And the last case, this is unhandled erroring. So what happens when HostOS crashes without proper notifications or core dumps? What happens is DPU OS crashes or core dumps, like unexpected problems in DPUs and APUs when no kind of notification is possible. So how we handle it, or we declare there is no fix for this problem and user should just deal with this. And that's it. I feel that boot sequencing was quite neglected in the past several weeks. I focused myself on the inventory, as you saw previously. So nobody kind of handled the boot sequencing so far. So I do expect that we should pick up and tackle boot sequencing a little bit more aggressively. I heard Red Hat is looking into more aggressive approach on the boot sequencing resolution. I'm all forward and very accepting for somebody to deep dive into this and try to propose a solution on each and every use case here or any of those. So please feel free to start a conversation on Slack, email, or pull request, whatever you feel like. I want this to move forward. Any question on the boot sequencing? Let's quickly do the life cycle. Feel free to stop me and ask questions. I'm really open to any discussions. We're just recapping what's going on. So thank you for Steven. He created this first page for lifecycle management. This is a high-level requirements. So Steven wants us to find a way to reboot a device, to update a device, firmware, OS, and software applications on the device. We want a way to recover a device to a known good state, for example, factory reset, either via network or via host. And we need a way to debug a device as well. So some of this is covered in boot sequencing and monitoring. Some of it is not covered at all, but I think that lifecycle management is all about exactly that. Reboot of the device, update the firmware, OS images, and stuff like that. So either we cover it, for example, Intel suggested we do it via Redfish. Again, I have no problem doing that. Either we add new RPCs to gRPC as well, how we do the factory reset, how we do all of that stuff that is mentioned on this page. So thank you for Steven for starting this page. And this is a good conversation to have. So if people have opinion and working on these work streams, feel free to deep dive and suggest a way to do so. Maybe this is tightly coupled to inventory work for the local, remote, and others, or it's completely different. I don't know. So feel free to suggest what do you want, how do you want this to look like.
And just a quick
yeah.
question on that one, Boris, if you go back to that list. Via network, so are we talking about inbound network, outbound network? If I have, for example, on IPU, if I have separate manageability port or I don't have it. So which network we're talking about here? So
Yeah,
we need to
good
clarify
question.
it.
Good question, and I don't know. So if there are limitations, we can definitely in this section we can specify via network, and then we can create a two sub bullets: the management network and the inbound network, for example. The host is also, there is no much details here, but the host is also like host. Are we talking about OS or are we talking about BMC as well, right? The solutions could be completely different for those. But this kind of the same notion that we talked about previously, like for inventory. So we can correlate as well here.
Yeah, and I think it will depend on, especially when we're talking about host. We go back to this discussion about trusted, not trusted. So which is a trusted entity?
Exactly.
Not trusted.
Yeah. So yeah, host is OS and BMC, network would be management and inbound. I'm not sure which is optional, which is required. So yeah, feel free to propose whatever we need. Obviously for Intel, you advocated for Redfish server running inside the IPU previously. So I would feel that at least the network part can be covered by Redfish commands, but maybe not necessarily. This is why for inventory, we also created protobuf with gRPC. So maybe we add a new RPC call for factory reset over there as well for that service. So again, I'm very open for suggestions. Same for firmware updates. Either we do it through Redfish or we create another gRPC service. If we've been on the call, I believe that you're doing everything over gRPC. So you
That is correct, yeah.
So both firmware update, OS upgrades, software application update, reboots, factory reset, all of that is handled by gRPC in MDeep and Sound example, for example. In Intel, you're doing all of that using Redfish server, for example. So that's fine. In any way, the host is not solved, I think, properly anywhere. So from BMC and from HostOS. Again, we're talking about PLDM, we're talking about NCSI, we're talking about VPD, we're talking about all the different methods over PCI Express, in-band, out-of-band, how we do that from the host. I'm not sure we have a good idea how to do it. The last one is monitoring and telemetry. This was kind of quiet for a very long time. I did run Open Telemetry Collector and Telegraph on the different DPUs and IPUs to collect all the different system information, and then we got stuck. So we didn't advance beyond just running the Open Telemetry Collector on the DPUs and IPUs. From Intel, I never heard if you can run OTEL on the DPUs and IPUs as well. So if you can, we can also update it for Intel as well. But basically, we need also to move it forward. So we need to show how SDK can be compiled with like SDK from Intel Marvell and Deep Pensando and others can be compiled with OTel to show how can we stream to open telemetries from inside the DPUs from the application and not just system telemetry. We also can deep dive into eBPF. eBPF collector was recently donated by Splunk to the open telemetry community, open sourcely. So for people who collecting eBPF can use that plugin now. So this is very nice work as well. Telegraph, for Telegraph, I created a lot of metrics that we can collect in addition to what we already collect, but most of them are focusing on two things. First of all is system metrics. So everything you can get from Linux, either using sysfs or ETH tool or others. Or I created a plugin for Telegraph and Open Telemetry to stream SPDK metrics. So we can definitely cover with OTel all the different NVMe emulation and SPDK framework that we're doing. So using my example that I already created, we can definitely stream all of that from SPDK as well. So two things we will already cover. We can definitely start to cover network things, like I said, with eBPF and ETH tool and others. This is a list of things that we can consider as plugins for Telegraph, for example, right? So GNMI, bonding, CPU, disk, DNS, Docker, DPDK, ETH tool, interrupts, IP tables, kernel, memory, netstat, NFS client, Nginx, sensors, SNMP, and syslog. So all of that are in addition to the different metrics that we can stream already today. This is a working example of Telegraph. It doesn't have a separate repo, so I'm still keeping it in OPI provisioning lifecycle. Doesn't have enough content for a separate repo yet. So this is already using Redfish, HTTP, CPU, memory, network, GNMI, DPDK, and others. And also I created for SPDK as well. So we can actually plug in into SPDK using RPC proxy and stream all the metrics to the InfluxDB Telegraph and then present them in Grafana like this. So all of that is demonstrated in this Telegraph node. Any questions on the metrics and monitoring? All right. So I think this was tons of information. I think mostly focused today on recap of what the work group is focusing on. I'm really glad to hear all your feedback, and hopefully next week we'll start showing even more progress. For now, please review what I showed you, especially the inventory stuff with protobuf and implementation. Intel has also a few action items as well, so feel free to reach out and see you next week.
Thank you.
Thank you.
Thanks,
Okay,
Boris.
thanks, Boris.
Thank you.
Thanks,
Bye.
Boris.
Thank you.
Bye.
Bye.
Bye.